Okay, lesson 9 of electrical module. So, lesson 9 is all about electrical safety. It's remarkable how few electrical fires there are nowadays, and that's down to really three key safety features in all of our houses, and they're in the walls, they're hidden away, they're inside plugs. You just don't notice them, and so we treat electricity really flippantly. We just plug stuff in, and it just works. So, first one is inside the plug. So, the plug itself. Let's have a look. So if you were to open the back of a plug, and most of them are sealed now, but however, if you could, this is what you'll see. And there are three wires, and you're expected to be able to name the wires by the colours. So if we look, we see there are three colours. Now, you might be wondering, why aren't they red and black, like the wires we use at school? And that's because in the late 70s, early 80s, the government changed it, because if you're colourblind to the colour red, then you're just seeing black and black. Whereas most people, even with colour blindness, can distinguish between brown and blue. So that's why they changed them. Let's draw in, if you could copy the sketch out of your revision guide or off this page thing here, we'll draw in the first one here. This is called the neutral. The neutral has 0 volts. We sometimes call it the negative when we're using black wires. However, in this case, it's 0 because there's no current flowing through it. No voltage. Okay, 0 volts. Okay, on this side, that brown one there, that is called the live. And that one carries the mains, which is 230 volts. Now, there's a trick to remember which way each one goes. On the left, we have blue. B-L-U-E. Let's take the letter blue. Let's put blue down here. L for left. Next, this one is brown. B-R-O-W-N. Can you see the trick? Let's get the brown. Go second letter down. Right. So that's the trick on how to remember which goes left and right. The brown is live. You don't want to touch that. That'll kill you. The neutral is 0. Isn't going to hurt. And finally at the top here, and it's got a bit of green in it, like the earth. And that's because it's called the earth wire. And we're going to look at that in step 3 about why that's useful to keep us alive. So the earth will, when it's working, it will have 0 volts. If there is ever any voltage across that though, then something's gone drastically wrong, and we'll talk about that in a minute. So the final one there is the earth. Now that's a correctly wired up plug. You'll notice this part here. This is the fuse, and the live is going through here. The voltage goes up, through, and through the wire and into the plug. So in fact it'll come through the plug, up, through, down, into the appliance, which would be off here, I don't know, TV or something. So you've got your TV, and the voltage will go in, power the TV on, and then the current will return up the neutral and then go back onto the circuit to be renewed. Okay, so let's have a little look at what this fuse actually does. Fuse. Now, you might see fuses around the house. They're usually in the second drawer down in the kitchen, in the odds and sods drawer, with scissors, sellotape, bit of old blue tack, and stuff you might just need one day. Oh, is that just me? You'll notice here they've got different amounts of current written on them. 3 amp, 5 amp, and 13. And that's because fuses are designed to burn out. If 4 amps went through that fuse, it would fizzle out. But 4 amps would get through that one. So if you're plugging into something that's little, like I don't know, a little lamp, then you probably only want 3 amps maximum. And if 4 amps tried to go through, then the fuse would burn, and that would protect my lamp. But if we took something big, so say we took your washing machine. Okay, so you got your washing machine. Now that takes a huge amount of current. For that, you wouldn't want a 3 or a 5 amp, because they're just going to burn out. This probably needs about 8 amps. So you would plug in a 13 amp fuse. And the rule of thumb is with these, is you always plug in the same amount of fuse as you took out, as long as it was the original. Okay, so we'll write that down. We'll write fuses. I'll make this a bit smaller. Fuses are wires designed to melt with a certain predefined current to protect components. So everything that plugs into the wall has to have a fuse somewhere on there to protect the component that's plugged in. And without it, if you were hit by lightning or there was some sort of surge on the national grid, your TV, your computers, everything would blow up and it'd be very expensive. Whereas fuses cost a couple of pence. So that's the second one. That was number 2, fuses. Fuses, number 2. Okay, the final one, the one that you hope you will never need. I want you to imagine for a second someone's got some faulty electrical equipment and the live wire has accidentally touched the outside metal case. So look around you now. What is plugged in around you that has metal on it? Imagine that live wire has come loose and it's touched the metal case. Well, electricity is always looking for the easiest route to pass, and so the current will flow through the loose wire, up the metal case, and this time it will go through this nice human being who's connected to the ground, and so it will try to make a loop, including you in the circuit, and at that point you will get electric shocked. If you are killed, it's electrocution, and you don't want that. So what do? We add on an earth wire to all our circuits. So here we've got the electricity coming from the mains. It's going to, in this case, a meter, and it's going to a fuse box. So here we've got my fuses, but also we have a earth wire, and every connection into the wall has this extra wire connected. Now, you'll notice it says to the water and to the gas. That's because those are connected to the earth. So the pipes are in the ground, the gas pipes and that. So what would it look like? So if this was the wiring coming in for a TV, for example, you would run the earth wire off to the side and connect it to the metal case. So now, if we revisit this scenario, if we add on, and I'll do it in dark green and do it thin because it's quite a small picture. If we now added on here an earth wire, then the live will actually go to the case and then it will come around, and the earth wire would trace back along here, back and into the ground, and so the current would ignore the person. It would go into the case, round the case, back through the earth and dump into the ground, and the person would be very happy about that. The first thing you'll know if that ever happens and you haven't been electrocuted is the surging current will turn off your fuses. Now, because you don't want fuses that blow all the time, you can imagine that happening in the middle of the night, we have a type of fuse that's a switch that you can actually click, and so you'll have somewhere in your house a box like this called your fuse box, and you click the buttons up and down, but all of it requires an earth wire. So that's our final bit to write down. So number 3 is earth wires. We can say if a live wire, let's put the voltage next to that, 230 volts, touches a metal case. Let's give an example, e.g. kettle. Then anyone touching it will be electrocuted. To protect us is, to protect us, we attach and let's put it with a capital at the beginning, an earth wire. I'll come back to highlight that as a keyword in a bit. An earth wire that will carry the dangerous current away. And so you don't get electrocuted. And that's it. Take care.